Let's talk about the angle between two vectors. So we're going to imagine that these vectors here have the same initial point. So let's say my vector u goes off this way, u, and then my vector v goes off this way. It's vector v. And this initial point, we're going to think of it, though I didn't draw it, this is the origin. And I want to talk about the angle between these two vectors here, this angle theta. Well, really the farthest these two angles could be apart is that they're on opposite sides. So the biggest this angle could be is 0, or sorry, the biggest it could be is pi, and the smallest it could be is 0. And then if I fill in this picture, this vector from here to here, this vector would be, would be v minus u. And so I want to know information about this angle theta. I do know it's between 0 and pi, but I want to have a way of actually computing it. And there's a nice formula for that. So if theta is the angle between two non-zero vectors u and v, where, again, theta is between 0 and pi, then what I know is cosine of theta is u dot v over the magnitude of u times the magnitude of v. So there's this really nice formula, and I'm not going to go into too much detail about where this formula comes from, but there's this nice formula telling us information about the angle theta. All right, so now I'm going to write down one more definition. So I'm going to say that the vectors u and v are orthogonal when their dot product is 0. So orthogonal here, you can think of it as being kind of the equivalent of perpendicular. So there's a 90-degree angle between the two vectors. All right, so let's look at a problem. Let's look at an example here. So what I want to do for the vectors u, which will be 3, -1, 2, the vector v, which will be -4, 0, 2, w, which will be 1, -1, -2, and finally z, which will be 2, 0, -1. Find the angle between each pair of vectors. So let's start with the first pair we're going to look at is u and v. So let's look at our formula here. Cosine of theta, it's u dot v over the magnitude of u is the magnitude of v. So I'm going to look up here at my vectors. Okay, here's my vector u, here's my vector v. Let's compute the dot product. 3 times -4, -1 times 0, and 2 times 2, divided by, now let's find the magnitude of u. It's the square root, 3 squared plus -1 squared plus 2 squared, and the square root of, now find the magnitude of v, -4 squared, 0 squared, and 2 squared. So if you simplify the numerator, you'll get -8, the square root of 14, times the square root of 20. And you can simplify that down into -4 over the square root of 70. And that's what cosine of theta is. Now what we really wanted to know what theta was. So here to find theta, you're going to have to use your calculator and take the inverse cosine or arc cosine of -4 over square root of 70. And your calculator will split out that theta is approximately 2.069 radians. Let's look at one more angle between vectors. So part B, let's look at the angle between U and W. So if I compute cosine theta, it's the dot product of U and W over the magnitude of U, the magnitude of W. You're going to get the dot product, it'll be 3 plus 1 minus 4, square root of 14, the square root of 6. You're going to get 0. So think about your unit circle. Where is cosine theta equal to 0? It's when theta equals pi over 2. And remember that we know, so I'll mention note here, that we knew that the dot product was 0, which told me that U and W are orthogonal, i.e. they're perpendicular. Okay, one final one. Let's look at the vectors V and Z. So if I compute cosine of theta, if I compute this dot product and divide by the magnitude of V, the magnitude of Z, you'll get -8 plus 0 plus 2, the square root of 20, the square root of 8. Wait, you'll get, let me double check something. That should be a -2, yep. This part right here should be a -2. So we'll get -10. And this should be the square root of 5. Sorry about that. Square root of 100. So you'll get -1 from this. So again, think about on the unit circle, where is cosine equal to -1 when theta is pi? Well, if theta's pi, right, the angle between these two vectors is pi. What do we know about these vectors? If the angle between them is pi, these vectors are parallel. So I could say that v and z are parallel. In fact, v is -2 times z.